not without a pretty big cost of entry.
Designed during the Cold War and delivered after the fall of the Soviet Union, the change in defense priorities meant that only a handful of these bombers were ordered, 21 in total. This time around, the Air Force plans on buying in bulk, with roughly 100 B-21s planned and the possibility for more on the table.
The B-21 looks very similar to the B-2 because the fundamentals of stealth and long-range penetrating air are built around the concept of a flying wing, and that even goes back to the YB-49 when Jack Northrop actually created some of the first flying wings.
The B-21 is also the first modernized element of the so-called nuclear triad: land-based nuclear-armed intercontinental ballistic missiles, or ICBMs, submarines with nuclear-tipped missiles, and bombers that can carry nuclear weapons make up the triad. If one leg of the triad is eliminated by surprise, the others can still retaliate in the event of a nuclear war.
This is the Northrop-made bomber, touting a space-age stealth coating. It has the ability at some point to fly without a pilot. It's designed to deliver conventional and nuclear weapons.
The U.S.'s bomber fleet is getting old. If the Air Force is going to keep ahead of the competition, then the B-21 must rise to the occasion. Stealth is what separates the B-2 from every other bomber. The shape of the aircraft combined with radar-absorbent materials keep the radar cross-section, or what is detected by radar, much smaller than non-stealthy aircraft. The B-2 effectively shrinks the ability of the enemy to see it, creating paths to targets that otherwise would be much tougher to navigate. The B-2 can fly far, up to 6,000 miles without refueling, stay undetected, and hit targets with precision.
And when I think about the mission statement of the United States Air Force, the fly, fight, win, air power, anytime, anywhere, that's what the B-21's about.
The B-2 is dependent on computer systems to calculate its fly-by-wire system and to keep the flying wing design stable. In 2008, one of the expensive aircraft crashed in Guam during takeoff after a sensor was compromised by moisture, which led to a cascade of errors by the computers needed to fly the plane.
We have a handful of B-2s. The B-2 program started in 1976. So the stealth technology, the avionics, the logistics, the cost to support that program, simply put, are outdated.
In December 2022, a B-2 Spirit was damaged during an emergency landing. Not much is known about what this means for the aircraft in question, but it could end up being costly for the Air Force. This is one more reason the Air Force is aiming for triple-digit production numbers for the B-21. It would decrease the impact on the Air Force if an aircraft was lost due to accidents or combat. The Air Force has been contemplating how to replace the B-2, B-1, and B-52 bombers for decades. The B-1B Lancer is a supersonic bomber that is treaty prohibited from carrying nuclear weapons. It's also maintenance intensive and getting older. And the B-52 has been in service since the dawn of the nuclear age. It's likely they will be in service for over 80 years before the last one is retired. They will most likely serve alongside the B-21 as a non-stealthy counterpart.
Believe it or not, the B-52, which has been around for a very long time and will likely keep flying past its century mark, is going to continue flying right alongside the B-21 Raider, in large part because it's just really economical and easy to update. So the future of America's bomber force will actually be its oldest bomber and the most advanced and modern stealth bomber the world has ever seen.
The B-2 is not an inexpensive aircraft to operate. Each flight hour costs around $150,000. With modern logistics and lessons learned from operating the Spirit, the Air Force is hoping to drop that number for the B-21.
We've taken a lot of advantage of the digital environment that's now available, coming off of a lot of commercial advancements, but then applying them in a weapon system environment to design the aircraft more efficiently, to design it with a lot more precision, and design a lot more functionality and adaptability into its architecture.